Dad, I just want to say that like our speaker today is Dr. Deb Hilbert. She wears a lot of different hats. Many Trees Consulting. She's also the president or the executive for the Florida Urban Forestry Council. She's she's currently teaching as well for some of the online courses for University of Wisconsin Stevens Point for arboriculture. So she's done a lot in our field, and I feel very fortunate to have her here today. And today she's going to cover some of her work that she's done looking into below ground spaces and tree size. And there's a lot to be said there that probably there's not enough said really. So with that, I'm just going to go ahead and pass it off here to Deb.
All right, thank you, John. And thanks everyone for coming today to attend this talk. I started off as more of a biologist and horticulturalist in my early studies and never thought I'd have so much fun talking about sidewalks, but it seems like that's the thing that's most important to talk about. So I look forward to sharing some of the things that my colleagues and I have learned about trees and sidewalks and other hardscapes. So like John said, I am a researcher and consulting arborist and urban forester. I'm also the executive director of the Florida Urban Forestry Council. And then I do some teaching and research on the side in collaboration with a couple of universities. This research and the applications I'm sharing today were done with several different teams. So the first one was done with a group of researchers looking at large trees in hardscapes. So here's that crew. And then that turned into an EDIS article, which is going to be the main focus for you all today. So we had some help from Brooke Moffis, Joanda Rowell, and some other folks for that one. And then we had a follow-up study on small stature trees, which I will also talk about. And this is a more recent paper that came out. So thanks to everyone who worked on these. It wasn't just me doing this research. I'm lucky that I get to talk to you about it. The reason that this topic is so critical is because more and more of the world's population is moving to urban areas. According to the United Nations, about 68% of the world will be living in an urban environment by 2050. Already 82% of people in North America live in urban environments. And then you probably know this, but about 91% of Floridians live in urban environments. And the urbanization is not only defined by density of people, but it's also defined by the expansion of built landscapes, so impervious surfaces and densification. The conversion of land uses to impervious surfaces is usually what is denoted during this development process. I want to show you real quick a map of Florida's developed, protected, and other land uses from 2010. This was part of a project done by 1,000 Friends of Florida, UF, and FDACS. And so they were looking at, again, developed areas versus other land uses. And if we continue to develop at the same rate and the same pattern, they estimated that Florida will look like this in the next 50 years. So that red is denoting the developed areas. So 2010 and then 2070. So we're looking at a lot of impervious surfaces. We're looking at a lot of urban densification. And this is a concern for people like me who want to make sure that trees and green spaces are incorporated into these areas. At the same time that we're expanding and redeveloping urban areas, there's also a call for more green spaces. This is awesome. This includes an increase in tree planting programs, canopy cover goals, and also a focus on tree equity to make sure that the benefits of green spaces are distributed equally to all people. It's tricky, however, because a lot of times green infrastructure elements like trees are an afterthought in urban design and planning. And additionally, in many of the places where these trees are needed, the landscape is very built up. Because trees are an afterthought in planning and design, the spaces for trees are usually inadequate, especially for large stature shade trees. And this creates issues down the line. I know you're aware of this. We have costly repair repairs to hardscapes. It also can lead to mass removals of trees. We see this a lot in Florida, where we have developments that were created about 20 to 30 years ago, and trees were planted in small, like right-of-way spaces, and now they're having to be removed because of the damage being done to the hardscapes. So it's not uncommon in Florida to see headlines like this, where there's 90, 100, sometimes even 1,000 trees being removed because of conflict with infrastructure. In addition to causing issues to adjacent sidewalks, curbs, and streets, having trees in small spaces also causes rooting issues, soil compaction, and there's more likely to have damage done to those tree roots during construction activities. So root pruning close to a tree's trunk is common during activities like sidewalk slab replacement, and it can cause a tree death, health decline, and also instability and total failure. And we have seen this. So in cases where large trees are in small spaces and their roots are kept at a shallow surface, they're more prone to wind throw, especially when those soils are saturated during storms and heavy rain. And also if there's any root pruning activity, like what comes along with the installation of new curbs and hardscapes, that tree is going to be more likely to fail. So we're trying to avoid this. The focus of this talk and this issue today is going to be on the root crown. So I'm not going to focus so much on the below ground stuff today. We are talking about the root crown region. And this is the area where the trunk is transitioning to those large structural roots. So at ground level, where it's transitioning, we have a region called the trunk flare. This is where the base widens out and these structural roots emerge, usually at soil surface. Sometimes we don't see the trunk flare in urban areas because the trees have been planted too deeply. That's a totally different issue altogether. We're not going to focus on that. But just know there should be a flare. And then beginning where these roots emerge to several feet out is the zone of rapid taper, sometimes called the root plate. So that's where we have these large structural roots coming off of the trunk flare, and then they're rapidly getting smaller. So just beneath the soil surface, these large structural roots are essential for supporting the tree. In urban areas that have really compacted soil or poor drainage, sometimes that root plate area can be pushed really high up to the surface. You might actually see like an old live oaks and laurel oaks. They almost look like they're like raised above the rest of the soil level. So that is this region, this root crown region. And so this is what we're going to focus on when we're talking about avoiding damage to adjacent ground level hardscaping. Okay, so our team sought out to build on some earlier work that was done to estimate the size of a tree's trunk flare in order to make smarter planting decisions. So our focus, again, was trees in the right-of-way, particularly those adjacent to sidewalks and streets. And we were not concerned with underground stuff. There are plenty of resources about below ground requirements for trees. So the UF IFAS website has some recommendations for soil volume. We don't care about that today. What we care about is ground level. We want to know what are the minimum planting distances and widths needed. So for our research, these were our main goals. So we wanted to look at the relationship between tree size and damage to adjacent hardscape. We wanted to examine the relationship between stem diameter at breast height, and trunk flare diameter, and also site characteristics. And then we wanted to create equations that relate trunk flare to diameter at breast height. So can we predict how big B is going to be if we know A? And then we wanted to use that to create simplified equations that people like you can turn around and use on a daily basis. So here were our study areas. For our small stature trees, we did research on trees in Central and Southwest Florida, and we looked at a total of 288 trees. And for our large stature trees, we were looking at trees in Minneapolis, in St. Paul, Milwaukee, and in Tampa. and we had almost 1,500 trees that were measured. Here are the medium and large stature trees. You don't have to remember all of this. But I do want to note that the species with the asterisk, those are species that we were able to create species-specific equations, which I will show you later on. And then for our small stature trees, many of these should look familiar to you. These were the ones that we measured in Central and Southwest Florida. What we did is we measured the diameter at breast height when possible. If the tree split before then what we did is we dropped down to 6 inches. And then for some of the trees that were multi-stemmed at the base, we measured at 2 inches. So we have 3 different diameter heights. And then we also measured the trunk flare. This is a trickier measurement to get. You have to be trained on it. We had to do a lot of calibration within our group. And we came up with a method for trunk flare measurement by putting in like field flags where we saw the trunk flare transitioning to root tissue. And then we wrapped a tape around it and then calculated the diameter. So that was a pretty clever idea. Rob Northrup came up with that and it worked really well. So we also wanted to look at things beyond just the diameter at breast height and the trunk flare and damage. We wanted to see if things like stem girdling roots, tree condition, boulevard width, ground cover types, whether or not there's irrigation, if any of those factors would influence the shape of the trunk flare and the size of it. Turns out it didn't really, which is good for us. But these were all the variables we looked at. Okay, so first I'll show you some of the damage results. So for our large stature trees, about 21 to 39% of the trees were associated with some kind of damage to adjacent hardscaping. So that either recent replacements, sidewalk lifting, or cracks in the sidewalk or the curb or road. So large stature trees, again, about 21 to 39% of those trees had associated damage. It's a range because it depended on the city. For the small stature trees, there was an overall rate of about 11.5%. So only about 11.5% of those trees were associated with damage. Makes sense. Smaller trees usually cause less damage. But it's always good when the data shows that. Okay, so for this, what we're looking at is an odds ratio and distance from pavement. And then we have our small stature trees, our large stature trees. And really what this is saying is that a small tree is 20 times less likely to cause pavement damage when its trunk is 6 feet away from the sidewalk versus if it's planted right up against the sidewalk or pavement. So there's a big difference. The further you plant a small tree away from hardscaping, there's a much higher odds that it's going to cause less damage. With large trees, they're only about 5 times less likely to cause damage when they're moved out to about 6 feet. So in other words, they need a lot of space. Even at 6 feet, they're still causing way more damage than small trees. Again, this is pretty intuitive, but it's great when the data sets reflect what we already expect. I mean, this how we are collecting good data. Okay, and then for this table, what we're looking at is the estimated per tree savings and sidewalk replacement cost as you move further away from, as the tree moves further away from the pavement. So this is for small stature trees. And the example I want to show you is if you were to plant a small stature tree about 3.2 feet away from pavement versus right next to it, you're going to have about $120 per tree savings. So not bad. It's going to save you a little bit of money. However, with a large stature tree, in order to get the same amount of savings, that tree would need to be 6.5 feet away from the sidewalk. So again, large trees need a lot of space, especially if you're trying to save money. Okay, so we also, one of our goals was to create those predictive equations. So figuring out if we can estimate trunk flare diameter from diameter at breast height or one of the other diameters. And so I hinted at this, but factors like ground cover, stem girdling roots, those actually did not affect the trunk flare diameter size, which tells me from a biological standpoint that there is a there's genetics going on that's influencing the shape and the ratio of the diameter to the trunk flare, that's consistent across whether that tree is in a lush lawn or a tiny boulevard, etc. That's really good for us because we are able to use simplified equations that then managers like you can use. You don't have to use like a really complex equation for estimating trunk flare. So that was a good finding. Here are the equations we came up with for our large species in our study. And so basically what this is saying is for example, a Norway maple, the first one on the list, the estimated trunk flare diameter, that little hat just means estimate. So you can get an estimated trunk flare diameter by multiplying the diameter at breast height by 1.3. That's it. So if you can measure the diameter at breast height, use that factor right there, you can estimate how big the trunk flare is, even if you can't quite see it, or if there's a bunch of shrubs covering it, or you aren't really confident in measuring the trunk flare diameter because it is tricky. Well, now you can estimate it. If you're dealing with species that are not on this list, which is going to be the case, besides maybe Quercus lorifolia and Virginiana, we did create more generalized equations based on what habitat that species evolved in. And we used the USDA plants database for this. So if you look up the species on the USDA plants database website, you can find out what its wetland classification is. And then you can use one of these equations and it'll give you a really good estimate of your trunk flare. Kind of cool to note that the wetland species tended to have a much larger flare. And it makes sense because they evolved in saturated soils where they're going to need a wider base to help stabilize that tree. Okay, for the small species, it was another lucky situation where it didn't really matter whether the diameter was measured at diameter breast height, 6 inches or 2 inches. It really only made a trunk flare difference of about a few inches. So for science, it matters, but for you all who are estimating trunk flare for small species, it actually doesn't really matter which of these 3 heights you're measuring at. You can still use this 1.2 factor. So if you can measure at 4.5 feet, go for it. But if you are measuring a tree that branches off just below there, then you can drop down to 6 inches. Or if you have a multi-stemmed tree like this crepe myrtle, you can drop down to 2 inches and you can still use the 1.2. So again, another lucky thing in this study where it's like, yes, we can be simple. Okay, so how do you actually use these equations? The goal for us is to avoid damage to pavements. So not only do we need to account for the trunk flare diameter, which is what these equations are estimating, but we also need to account for this zone of rapid taper and these large structural roots that are just below the surface or even at the surface. They're what are creating crown rise and also cause damage to the surrounding infrastructure. There are some rules of thumb based on different studies on how much of a buffer you need to create for this zone of rapid taper. For large trees, evidence points towards about 4 feet of a buffer. For small trees, about 2 feet of a buffer. And then for tropical trees with the buttressing roots, you're going to need a lot of a buffer. You're going to need like 13 feet. So for trees like the silk floss tree, this is downtown St. Pete, they're going to be replacing this slab forever and ever because there's not 13 feet of buffer happening right there. Okay, so here is what the planting space recommendations really boil down to. If you want to plant a tree in the ground and have it grow to full maturity without any major conflict happening between hardscape, then you're going to need to use these equations, especially if you're using species that we develop the equations with. So you have to consider the trunk flare, which you get by doing that, using that little estimate equation. And then you need to include the buffer to account for this. And so for planting distance, which is on the left, so distance to a road where on the other side there's plenty of space, what you would be calculating is buffer. So for example, 4 feet plus half of that maximum trunk flare. If you're planting in a planting strip or a boulevard, people call it different things, you're going to need to basically multiply everything by 2. So you'll need buffer on each side and then the full trunk flare diameter. I will show you more about this. Also, this is in the EDIS article, so you don't have to memorize this today. This is all in the EDIS article. I just want to explain it to you. Okay, so we took our research a step further and decided to create species-specific recommendations using existing stem diameter data sets. So this method and the resulting tables are all in an extension article called How Much Space Does My Shade Tree Need? And I'll show you that at the end. I'm just going to explain some of the tables in the article so that when you look up the EDIS article, you're good to go. So what we did is we looked at planting lists from around the state, and we wanted to pick out the most common species that were found in urban areas. And then we looked at the maximum diameter that these species get. So we looked at like champion tree registers. We called this the maximum genetic potential, which means like if this tree were a champion tree, how big could it get? And then we plugged in those diameter values into our equations that we created for habitat groups, and we got an estimated trunk flare. We added our buffer, and then we developed the tables. So here are the tables, or an example of the tables. The full tables are in the EDIS article. But for this table, I want to point out a couple different things. So there is the species column. There is the maximum diameter at breast height of the champion. And then we have our estimated trunk flare diameter, which we just multiplied this times whatever our factor was from our equation and got the estimated maximum trunk flare diameter. And then we provided planting distance and planting width by adding the buffer. Now I know that not all trees in an urban environment are going to be a champion tree, which is what this column is. So we did reduce it down to, well, what if it was 75% of a champion tree size or 50%? I hesitate to go any lower than that because if we're trying to grow shade trees, we want to grow a tree that's gonna get big. But I have had people use the 50% and the 75% because they're like, oh, we've never had such and such species get to be that diameter. But this is something that shows up more consistently in our inventories, whatever. Anyways, so in this case, for like an Acer rubrum or a red maple, even if it only has a genetic potential of about 50% of its champion size, it still has a recommended planting distance of 6 feet and a planting width of 12 feet. So even if it only got to be half the size of its champion specimens, it still needs a lot of space. For the Royal Poinciana, again, even if it's only 50% of the maximum potential, it still needs about 5 feet distance from one hardscape or a 10-foot planting strip. We have a lot of species in this table and in the EDIS article, but obviously not all species. So we did create a table in that article as well for our different wetland classifications or habitat types. So if you have a medium or large stature tree that's not in the full table, you can look up the habitat type using the USDA plants database and then use these equations or these recommendations. If you need to get the estimated diameters for these species, you can look it up from like big tree registers, or you can look at existing urban tree inventory data and ask your colleagues who might have that data to get an idea of how big that tree is expected to get. So is that a species that tends to get to be as big as 40 inches in the urban environment? Then you should probably use these numbers, etc. Okay, so now I want to show you another way to use the equations. And again, it's using inventory data. So if you have this in your city or you know someone who has this data, instead of looking at champion tree registers, you can use diameter at breast height measurements from within your region, in your urban region. So this example is from Tampa, and we looked at lots and lots of inventory data of Tampa live oaks and found that they typically max out at around 48 inches diameter at breast height. So I plug that in. So the trunk flare diameter is going to be 1.7 times 48 inches. And then you do have to convert the inches to feet. Whoops. Oh, okay, sorry. So I multiply that and I get an estimated trunk flare of 81.6 inches. And then you do need to convert inches to feet. Don't forget to do that. Please don't forget to do that because you're adding 8 feet to it. So you convert, just divide by 12. And then you're going to add your recommended buffer. So for planting width, how big of a boulevard or a planting strip do you need, or a median do you need for a live oak? You add 8 feet. And that gives you planting width of 15 feet. You need a 15-foot wide boulevard or planting strip, or a distance of about 7.5 feet. Science. Again, I think most of you who work with live oaks on a daily basis are not surprised by this at all. Already, some cities have codified that you can't put live oaks within 10 feet of infrastructure, which is awesome if you can afford to do that. But I anticipate those of you who are looking at this are like, yeah, right, Deb, there's no way we're going to find space like this for live oaks in our city. Our planting strips are 3 feet wide, 8 feet when we're lucky. Yeah, I get it. But I don't want that to be an excuse for not planting large trees. And I don't want this number and it being so big to discourage people from looking at other solutions. Because the solution is not to cut down all the big trees and replace them with small trees. Scientists know that ecosystem services and benefits are related to leaf surface area. And large canopy trees like our live oaks, like all of our giant shade trees, they provide up to 60 to 70 times more leaf surface area than small trees. And so that means 60 to 70 times more shade, more stormwater runoff mitigation, etc. So if we're planting trees in our urban areas with the purpose of providing benefits like runoff avoidance, shade, in an increasingly hot world, then we need to make space for big trees. So I'm going to show you some strategies to make space for big trees and to avoid conflict with infrastructure. I'm going to kind of fly through these over the next 10 minutes because there's a lot that goes into this, but I just want to give you a taste for some different options, and then you can go back and look into them more, talk to people in public works, engineers, landscape architects, and figure out what might be applicable in your area. So the first conflict reduction strategy is just looking at the tree itself, selecting the right species. This is a preventative measure, prevents conflict from the get-go. It's simple, but the issue, which I've already hit on, is you're probably going to end up relying on only small stature trees if you are trying to just focus on putting the right tree in the right place with your existing infrastructure. Another conflict reduction strategy that's used a lot is root pruning. This is a corrective measure. It's convenient. Most arborists know how to do it and offer it. The con is it can reduce tree health and stability depending on the proximity and the number of cuts. and is not recommended to do near trees. And the whole point of this research is looking at trees that are really close to infrastructure. So any root pruning happening is going to be done really close to the tree. So I really want you all to avoid this as much as possible as your go-to. If it is selected, it really should only be performed by a professional arborist. And once the root pruning is done, barriers should be installed to prevent further damage and future root pruning. But again, this is a short-term solution. This is a West Coast example. This is a redwood tree that had some major root pruning. This tree ended up having to be removed. So Bruce Hagen over there came back, and that tree was removed because it didn't survive this root pruning activity. In this case, it's better just to remove the sidewalk and install a new sidewalk that just goes above the root problems. Another reason we want to avoid root pruning is because it can lead to this. So this is from Ed Gilman. This is a tree that had some severe root pruning done, and then it ended up falling through a structure. Okay, so those are tree focused solutions, root pruning and species selection. Now we're going to look at some design-based solutions. So this is where you'd be working with like a landscape architect, planner, etc. Larger planting space. This can be both a preventative measure, but also a corrective measure. You can go back and retrofit planting spaces. I'll show you in a second. A pro is it's supporting the tree health and lifespan, reducing chances of hardscape damage. A con is it requires space, which we know is a luxury in urban environments. And retrofitting can be expensive. I do know that. Excuse me. Knowing the expected size of the trunk flare, which now you know how to do, can help you estimate the planting space needs. And then curving sidewalks is another design-based solution, and it can be done either before the tree is planted or after. Similarly, it's good for the tree, reduces chance of damage. Again, requires space. Sometimes the space is created by obtaining easements into the beyond the right of way. So here's an example of an enlarged planting space. So it used to be right here. You can kind of see this large structural root right here, and then another couple feet were given to these trees. Okay, so some other design-based strategies, pop outs or bump outs. I'll show you a picture in a second, but these are preventative or corrective measures. Similarly to the last examples, good for the tree and the hardscape. Also traffic calming. So in downtown areas or areas where you have a lot of pedestrians and you want to create some more safety for those pedestrians, these are a really good solution. Require space, can be expensive, kind of goes with a lot of these. Also, the retrofitting also involves working with folks who deal in transportation and also stormwater, because it will alter those two things. Different slab size, this is not really used very often, and it's a corrective thing. So basically it means like you go from a wide sidewalk shrinking down when it's next to the tree and then widening back up. The problem with this is all sidewalks should still be ADA compliant and structurally sound. So there's only so small you can go. You need to still have 4 feet. The other example on this page is having the sidewalk adjacent to the curb. So instead of having street, planting space, sidewalk, you have street, sidewalk, planting space. This can be done before or after the tree is in the ground. Again, could help the tree out and reduce hardscape damage. Downside is there's a lack of a buffer now between pedestrians and traffic, which can be an issue on really busy streets. And then it can also reduce the amount of shading the trees are doing over the road. And that shading on the road is actually very helpful. It expands the life of road surfaces by a lot. Sometimes these are called monolithic sidewalks because it's going straight from the street into a sidewalk. So here's an example of a bump out. You can see the normal sidewalk comes out here, and then it bumps out a little bit, and then it bumps out a lot here. So this whole region right here is the bump out. So it's basically narrowing the car traffic and expanding the space for green space and pedestrians. These are becoming more popular in like downtown redesigning or redevelopment projects. All right, some other options: increase the right-of-way space. This requires space, also usually requires easements. You can eliminate the sidewalk. This is one that I've actually recommended when I've worked with HOAs. If there's already a sidewalk on one side of a street and the street is like a very super low traffic residential street and a quiet HOA, you probably don't need sidewalks on both sides. You can just have your big trees on one side and your sidewalk on the other, and make sure you have safe crosswalks. It's probably not feasible on busy streets, but it could work in these low traffic and cul-de-sac areas. Another option is, instead of having long rows of tree plantings, have tree islands or groups, which will allow for like a large planting space and then small planting space and a large. It requires a lot of redesigning and is usually done before any landscaping and hardscaping is installed. So this would be like during the initial planning and design phases of a new development. Having narrower streets. This kind of goes along with bump outs, but if you can reduce the amount of lanes or the amount of like street parking and expand your planting spaces, that can be a really effective measure. This is being done in a lot of urban areas. It can be expensive, and it's best implemented during the planning phase as a preventative measure, because retrofitting is usually more expensive, but it does work. Something that I don't see enough is bridging. So literally building bridges over that root plate area. And this can be done beforehand or after. It's an alternative to root pruning. It can be expensive. There's different types, but you still have to conform to ADA requirements, both with the slope and the width of that bridge and the material. There's also some more like engineering type things that are done. So modifying the gravel layer beneath the hardscaping can sometimes be used as a preventative or a corrective measure, because it can actually reduce the amount of roots that are going up to the surface and encourage them to go down. This is best done before tree root issues arise. And again, speak with an expert on sub-base layers in your region, not me, because this doesn't always work and it depends on what type of like gravel you're using. Okay, picture of bridging. So here's an example. This is from Savannah, Georgia, I believe. Should have put that on there. This is like a very elaborate bridge over this big oak tree. Here is a bridge made out of some kind of composite material over ficus. And then here's another composite material going over, this is a big eucalyptus in Australia. So again, if you do bridging, it still has to conform to ADA requirements, which is a slope of 1 to 20, and then width of 4 feet. And then yeah, there's some also caveats with when you have bridges. But I think this should be used more often. This is one that when I talk to like especially landscape architects who are dealing with tree root issues and they can actually like draw out the bridge, I'm like, you should look into bridging, because we need more examples of how it works. We need more examples in Florida. Okay, finally, there are some materials-based conflict reduction strategies. So one is reinforced slabs, so having cement slabs or rebar or are thicker, have expansion joints. This can be done before or after there are root issues. It reduces the chance of hardscape damage, doesn't necessarily help the tree though. It can also be expensive. And there's also no on how much reinforcement is needed. This is being studied right now. So Dr. Andrew Kozer and Jason Grabowski and some other folks are studying how thick and how much force a slab needs to apply. Whoops, sorry, I'm shaking my camera. In order to keep roots from damaging that sidewalk. but that data won't be analyzed for a couple more years. And then there are alternatives to concrete that might reduce some issues. They're usually cheap and easy to replace. Some options include pervious pavement, which is cool, but they're not as strong as concrete. And you, again, still have to conform to ADA standards. That's very important. And then these are the two that are pretty much always done. So grinding the sidewalk when it starts getting lifted, and or adding ramps and wedges. This is a corrective. It's easy, we know how to do it, but it's temporary. Okay, I do want to point out that these things are expensive. I know, I know. And I know a lot of you who work in municipalities who work with like public works and your engineers, they would look at this and be like, yeah, right. We don't have the funding for that. Well, there is some funding now, finally, for tree-related site improvements. So the Florida Forest Service has received federal funding from the Inflation Reduction Act, and they just got it, and they are working on launching their IRA-funded urban and community forestry grant program soon, like any week now. I talked to Todd Little from Florida Forest Service yesterday, and he's in the middle of creating the RFP. And a really cool thing about this IRA-funded grant program is that sidewalk removal or expanding planting space, that can be part of your planting project. I can't make up the full budget. Florida Forest Service isn't going to pay for a site improvement and no tree. They want to see a tree planted, but it will pay for some of it, which is awesome. But to me, that's huge. So if you want to keep an eye out for this funding, you can look at the Florida Forest Service's Urban and Community Forestry Grant Program, their website, and they'll post it as soon as it's official. And then Florida Urban Forestry Council, whom I work with, we're also going to make sure that it goes out to everyone on our mailing list, and it's on our website the moment these grants go live. Okay. So this is where I just want to encourage you all to not get bummed out by the fact that live oaks require 15 feet of median space. There are other options. So there are planners and designers who are looking to new urban designs and how to incorporate more green space into them and more space for trees. So this is where I want you to use your imagination and know that it actually is possible. We do things the same way over and over again because it's easy and the paperwork's easy and we know who the contractors are and we have the budget. But there are people like the Florida Forest Service who are willing to start funding newer projects because they know that we need to move beyond the typical planting space. And so, yeah, think big. And especially now, there's a lot of funding out for urban forestry, and you can argue your case for paying to make more space for trees. Because trees are really important. This is a hospital in Singapore. And as many of you probably know, even just looking at trees and green spaces can reduce the amount of pain reliever hospital patients take. It can reduce the length of their stay. It also can reduce stress levels in hospital staff. So studies like on hospitals and urban greens and urban walkable spaces, it all just reinforces the fact that we as people need to be seeing trees and green spaces. We have to. It's good for us. It's essential for our health. So we can't keep saying, well, it's too expensive, because healthcare is also really expensive and mental health care is also really expensive. And this green space can help reduce that. And this takes more than just arborists. It's going to require collaborating with designers and planners and engineers and public works and all the people that sometimes it's hard to get together in one room, but it is possible. It also requires talking to policymakers. So people on your city council and at a higher level, please talk to them. And then scientists who study all these things. There's lots of different people who work on this. There's also some other potential collaborators who you maybe have not thought of. So bicyclists are a great ally when we're talking about creating space for green spaces, because it turns out that a lot of the reason we have minimal subpar spaces for trees is because our cities are designed for cars, individual cars. We are very car centric in our urban planning here. Walking and cycling is kind of like last on the list. But there are people, especially bicyclists and people who want walkable cities, who envision flip-flopping this and focusing urban infrastructure on walking and cycling, which means a lot less impervious surfaces, a lot less hardscape, and a lot more room for trees. So I don't want to get rid of cars completely. I like cars. I nerd out over certain models, but we have to be realistic that the reason our cities have a lot of hardscape and not a lot of trees is because we have too much parking and streets and too many single cars. Okay, so some resources for those of you who are arborists or extension agents and want to like delve more into this topic beyond just the EDIS article. Here are some resources. The Seattle Transportation Trees and Sidewalks Plan is really good. Up by Roots, if you really want to nerd out, this is a really great book. And then this is a classic. This is a really small, oh, I don't have it, compendium of really the strategies that I went over towards the end of this presentation, but they give you more examples. Again, I want to thank my research team. And then there were people beyond the researchers who helped collect the field data, or like our partners and the local governments who provided inventory data and told us where to go find trees to measure. We also, part of the research was funded by FNGLA. So thank you to them. If there's anybody from FNGLA on the call, thank you. And then the folks in Wisconsin, they had help from some funders up in Wisconsin for those Wisconsin urban, for the Milwaukee trees that were studied. Okay, that was a lot to throw at you, but we have some time for questions, so I am here. Please pick my brain.
Deb, can you show that slide again with the name of the article, the EDIS article you were referring to?
Oh yes, here, hang on, we do.
Thank you.
Yeah, so this is the EDIS article.
Okay, good. Thank you. This was a great presentation.
Thank you. I know, I think it's a very, it can be a daunting topic because yeah, it's a lot. It's not just trees, it's planning and design and all those other stakeholders I talked about on this slide. So it can be overwhelming, especially to people who they just want to be told where to put the tree. But it does go beyond just where to put the tree. So that's why I really want to emphasize this.
Well, I feel like we're all facing the, the refits, because we're dealing with pre-designed stuff that doesn't work. So everybody's kind of trying to make up for mistakes that we made in the past. So it's good.
Well, there's still plenty of places that are coming in all the time. Are there any examples anywhere, Deb, where you can think of, like in the United States, that like have put a lot of these concepts into work, or somewhere that you can see this really on display?
Yeah, so parts of DC, they've done a lot of work on like using suspended sidewalk systems and even like reducing the size of the street in certain areas to make room for trees. Seattle is a good mix because they have a lot of infrastructure that looks just like ours, but then they have other areas that they've been retrofitting to make more space for trees, and also include things like bioswales and rain gardens along street sides. There's some work being done. Oh, I forgot which city. There's a city in Arizona, a smaller city, that's also working on converting their infrastructure to more like walkability, because they were very much designed for cars. And they're trying to switch that. But yeah, I would say the golden standard for examples would be parts of DC that are close to like the Smithsonian and stuff. And then Seattle. Miami has done some projects where they're using suspended pavement systems that include structural cells under the sidewalk. So should have put that example in here. I forget the name of it, but they did a whole redevelopment project where they made space below the sidewalk for the trees. My only thing with that is if you use suspended sidewalks and structural cells underneath, which are basically just like blocks created to hold up the sidewalk, but also allow for drainage and soil. Really awesome system, but you still have to account for the trunk flare and the growth of that tree and within the trunk and the trunk flare. So you still have to have some space up top, even if you have plenty of space underneath. But they did a pretty good job.
Yeah, looks like we're getting some people that are
Oh, good.
commenting on like there's some
Yes.
places in Florida where they're using solar cells and things like that. So yeah, let me try. We're getting a little inundated with messages now. In the beginning, it was a little slow.
No, this is
but,
good. Please show me your examples.
Hold on. Let me get.
Yeah, the
Okay.
Lincoln Road Mall. That's what I was thinking of. Yeah.
I got a question about the presentation. The recording will be available afterwards. Let's see. Does UF or anyone have any generic open source plan detail graphics available for insertion in sidewalk construction replacement plans to enhance existing tree preservation?
Oh, to enhance existing. I don't know if like the retrofitting specs are on there. There are. So Ed Gilman and some folks did create diagrams and specs that you can use for free. I think if you just search up like UF IFAS tree planting specifications, you'll be able to see it. I wonder if I can find those. And they're free to use. I think they were funded by the Florida Forest Service.
Okay, it's like I just now. Okay.
Yeah, if you get a question, you can either put in the chat, or I think I heard somebody try and say something like, but you can go ahead and mute yourselves too. Okay, let's see. Someone was asking about F and GLA and CEUs. If you signed up for the CEUs, we'll process that afterward for you. We'll send the forms and everything in on your behalf. Let's see. Okay, here's something from the chat. I hope that the landscape designers, and this is from Janine Griffiths, I'm one myself, architects and planners get to know that the plants need so that they can make better choices. It is sad to see trees suffering necessarily. Great presentation. They can help us start wrapping our heads around the topic in a functional way. Okay, so that more of a general comment, but yeah, seems to be very common sentiment there.
Yeah, I did give this presentation once that was aimed at landscape architects and planners, and we provided like ASLA and APA credits. Did not get as many planners as I was hoping though. But we're working, especially in the Florida Urban Forestry Council, who I'm with, we're working this year, especially on collaborating more closely with APA and the planners, because so many of urban forestry issues specifically also stem from design and planning level. So yeah, I agree with your comment. And I've also thought about, I'm going to give this I'm going to apply, hopefully I get chosen to give this presentation also at one of the upcoming urban engineering conferences. So we'll see if they choose me to be a speaker. Hopefully they're not like, trees, we're not interested.
I've done some presenting on this topic for like local chapters for landscape LAs, and like I kind of afterward I was like, was I too harsh? Like, like in trying to get this stuff across. But like on the other hand, it's like, how much is it talked about? I don't know. Like we're coming at it from the arborist side, arboriculture side, and sometimes we don't it's really tough bridging the gap between these fields. So I'm glad
Yeah.
that you're getting some success there, Deb, like, and reaching out to those audiences.
Yeah. I mean, people do want to collaborate across disciplines. It's just a lot of these projects do require money. And that's why I stress that the Florida Forest Service is going to fund some projects that include this type of work. Because I know that seems to be like the next the next hurdle. Once you can find a good team of people to work with, the next hurdle is finding the funding. But it is out there. Like that IRA funding, not only did it go down to the Florida Forest Service, it went out to other big groups, like American Forest, Arbor Day Foundation, sustainability groups of different kinds. So like they're also going to open up funding for planting projects. And that funding, because it was at a national level, that funding can partially be used on retrofitting of planting spaces. So there's money out there, and Florida Urban Forestry Council will be advertising. As soon as we get those RFPs, we're going to be sending them out on our website and social media and stuff. There's something else I was going to say. Can't remember.
I've got a couple here from somebody that said, I'm being asked to create a plan since the HOA is looking to cull some large trees and replace them with other species. I'm considering whether to accept this challenge, as I know the HOA will lose a significant amount of large canopy. And then this same person followed up with, is the NUCF program available to HOAs or only government agencies?
So it's only available to government, nonprofit, and educational institutions. Some HOAs are incorporated as nonprofits. Most are not, in which case they can partner. If there's like a local greening group you can partner with, then they can apply for the funding, but it would require like an added level of partnership. This is another thing we are talking to the Florida Forest Service about a lot, is that we need to find funding sources for HOAs. I get it. We're working on it.
So I know I asked earlier about examples throughout the country, like of getting, where these practices are put into place. And like people kind of expanded with like examples of seeing silva cells and things like that locally. Can you think of anywhere like maybe particular parts of cities or other, maybe like historic areas or something like that they've done a good job, like where if people wanted to see some really nice, like within the state, like within Florida?
So hang on, let me see if I can pull up. So Tampa's whole like waterfront redevelopment, they abided by, I think they had a 10-foot planting space minimum or distance minimum for their live oaks and other large stature trees. So their whole riverfront district, the newest redevelopment, there are some areas where you can see some really large planting widths and spaces for the trees in that area. Yeah, so I'd look there. The only other ones I know about are ones that are like in the works, they're not done yet. So yeah. Yeah, but the Water Street in Tampa is one to look at.
So I've got, I mean, if I don't get any more questions here, I've got something that I think about, like we talk about coat it and branches and pruning and all of that type of stuff, and how trees compartmentalize. And there's always this concept of like cutting outside of the branch collar, and I know that there's similarly, like there's root collars too. Do they serve as a similar function, and like in terms of being able, like an area that might be like a defensible area for the tree to stop decay coming in from the ground? Or
Oh yeah, that's a good question. No, not in the same way that like the branch protection zone is found under the branch collar. The problem with root pruning just in general is there's just so many naturally occurring pathogens in the soil, like Ganoderma and stuff, that any damage done to roots is like an entryway for decay organisms, in addition to all the stability issues. But yeah, I don't physiologically, I don't think it functions the same way as a branch protection zone.
Well,
It's a good question though.
I mean, do the roots have even more chemical defenses in them potentially compared to? I know that we're getting off on an aside here, but like
Biology tangent. No, not in the same way that branch protection zone does. There's like, yeah, it'll be a little bit different because you have to think about it from like an evolutionary standpoint. Trees evolved because their branches are constantly being knocked off, like either because they're shaded out or because of wind or whatever. In the forest, branches just are naturally falling off. That's what they do. So that tree had to evolve some sort of mechanism to close off that wound and prevent further damage. Whereas there wouldn't be as much damage consistently happening to the roots in a forest.
Okay. Yeah, that makes sense. No, it all goes back to design. Well,
yeah,
you know.
Yeah. Well, one thing I like pointing out is that cement sidewalks have only been around for about 150 years, but the live oak group or the oak group has been around for like millions of years. I forget the exact number. So you're fighting a losing battle if you're trying to put like a species that has evolved for millions of years inside of a structure that was only invented like 150 years ago. You're not going to like make it work with that. You're going to have to work with the tree if you want to succeed.
There's some conversation going on here. Someone said, anyone have experience with structural soil cells and performance with trees and hurricanes? We use them almost every project in South Florida and haven't had storm. Thank goodness, to see how they actually perform. And then I think there was some follow-up here. PVC, planning and zoning board, planning and zoning, published a street trees in a county road right away addressing root damage, sidewalks, utility lines. Committee conclusions and recommendations December 2001, but with few of the recommendations have been implemented. Oh well. Okay. I think that's kind of par for the course, unfortunately. But yeah, I'd be curious too if anyone has seen any of the like how those silva cells have held up, like in
yeah, it's a great question. I don't know. I'd have to look into it and see if there's any studies. But those of you who do have silva cells and trees and are in hurricane prone regions, you should reach out to a scientist. Because that's an awesome research question. I'm sure Andrew Gozer or John or me or Ryan Klein, any of us would be interested in helping with that.
We got somebody come on here. Somebody said the Silva made it through Irma and Miami Beach. So, but nothing published though is the other follow-up. So, well, hey, I guess it's about time. I would like to hang out and have more conversations about all this. Hopefully I'll see all of you in Deb, maybe the next Trees Florida, we can like have, I don't know, like a breakout session or something like, or an informal meeting, like for people that have been hanging out, like in our webinars. Because look at this, man, I think this is the nice thing about the webinars is that like we kind of expand it into conversation here. So, but yeah, I'm still reading stuff popping in. So, but yeah, I guess I just want to say thank you, Deb, for being our presenter, and I'm looking forward to hopefully, hanging out in the future and maybe having more of these down the road and seeing where, the rest of your trees and research career take you. So, because you've definitely have addressed some of the things that are huge problems, but often get neglected because it doesn't seem like that there are solutions for it. So thank you for tackling these.
Yeah, thanks for having me. I would love to come back and talk some more on this or another topic. So appreciate it.
Awesome. Well, all right, everyone, will take care. Have a good rest of your afternoons. Thanks, Deb. And we'll see you guys next month.